All right. Something that you need to know is that recursion is actually not going to be part of the free response on your AP test. It's only going to show up in multiple choice. So you're going to be mostly interacting with the output of these functions and trying to figure out what do they do, how are they going to output. Now, one of the sneaky things they can do um, is what I'm about to show you. So look at this function right here. I'm just calling it recur. Um, and usually on the AP test, they'll call it something like mystery or you know, you know, question or whatever. Like it doesn't want to tell you what it does because that's going to be what you're trying to figure out in the answer choices. Um, but look at this guy. So what it does is first it prints out n, and then if it's as long as it's greater than 0, it's going to go ahead and reduce n by 1 and run it again. So for fun here, let's call recur n. Okay. So, or sorry, recur 5. Now if we call recur 5, n is 5, so it's going to print out 5. And then it's going to put recur 4 on the stack. Well, it's 4, so then it's going to print 4. And then it's going to call recur 3, and it's going to print 3. And then it's going to keep doing that. You can't see that, sorry. 5, 4, 3, 2, 1. It's going to reach 0. And then it's going to stop recurring. Okay. And once it does that, there's nothing left. So all of these will disappear off the stack. And what's left is this printing right here. And you look at that and you go, okay, well, that's fairly straightforward. I probably could have guessed that that's what's going to happen since we're recurring in -1. But let's make a small change and see what the result of that change is. So all I'm going to do is I'm going to move this print statement to after our recursive call. Now, that doesn't seem to be like a huge change, but it's going to actually change our output considerably. And it's going to be a really easy way to trip you up on the AP multiple choice. So the same thing, let's call recur 5. Well, first thing is it's greater than 5, so we call recur 4. Now, when we call this, everything stops. We do not continue with this until everything on the stack has been resolved. Well, we call recur 4, and again, we don't make it down here. 4 is bigger than 0, so we call recur 3. And 3 is bigger than 0, so we call recur 2. And then we call recur 1. And then we call recur 0. Now, none of these print statements have happened. And then, when we hit 0, this guy doesn't run. Okay, we get to skip this guy. And then we print out the value of n. Well, what is the value of n right now? It's 0. And then now that this one has resolved, we get to resolve the next one on the top of the stack. Remember, it's last on, first off. Last in, first out. So then we print 1, then 2, then 3, then 4, then 5. So based on whether or not that print statement happens before the recursion, the recursive call, or after the recursive call, the order that it resolves winds up being a little different. So as just a quick rule of thumb. You'll still probably want to do some code tracing anyway, run it and just see what happens. But as a rule of thumb, if things happen before the recursive call, they're going to happen in that particular order that things are being called. If it's after the recursion, it's going to happen in the opposite order from the way things are called. So be careful on the AP test. Don't let this opposite order thing get you. I would do some code tracing just to make sure that you know what you're doing, but that's a good rule of thumb there.